well, I'm going to be talking about how the transmitters and the receptors work together when they're being inhibited by drug use. And so first I'm going to be talking about alcohol. So inhibitory neurotransmitters are called GABA, and they're active throughout the whole brain. And then these neurotransmitters act to control neural activity along many different brain pathways. And what GABA actually does is when it binds to the receptor, the cell is less likely to fire off. And then when alcohol enters the brain, it delivers a double sedative punch. And at first, it has to interact with the GABA receptors to make them even more inhibited. Then second, it binds to the glutamate receptors, preventing the glutamate from exciting the cell. All right. Second, I'm going to be talking about methamphetamine. All right. Dopamine transporters are responsible for removing dopamine from the synaptic cleft. Because meth mimics dopamine, it is taken to the cell by the dopamine transporters. Once inside the cell, meth enters the dopamine vesicles, forcing dopamine molecules out. And the dopamine cell, or the dopamine within the cells, because there's such an excess of it, it starts to make the transporters work in reverse. And then it dumps the dopamine out of the cell into the synapse. And then the excess dopamine that is pushed out into the, what was it called? Out of the cell wall into the synapse. And then it's trapped in the synaptic cleft. And as a result, it binds again and again to the receptors, overstimulating the cell. Yeah. The third one is ecstasy. So what happens is the serotonin, that's what's being used. So serotonin transporters are responsible for moving serotonin molecules from the synaptic cleft after they have done their job. And so pretty much ecstasy is what it mimics serotonin, and it takes up the serotonin transporters. And ecstasy is more readily taken up than serotonin itself. So it's just building up, and there's just so much of it. And since there's so much of it, the interaction with ecstasy alters the transporter. And the transporter becomes temporarily confused and starts to do its job in reverse. The transporter starts transporting serotonin out of the cell. Such as the methamphetamine. All right, now we have cocaine. Cocaine blocks these transporters, leaving a dopamine trapped in the synaptic cleft. As a result, dopamine binds again and again to the receptors, overstimulating the cell. And yeah, so it also, it kind of overloads the way the reward system works in the brain. And what we know and how it affects you physically, it just constantly makes you move. So someone who is abusing cocaine is never going to be able to sit still. They're going to be so jittery and they're just shaking constantly. And yeah, there we go.